stick to your time. So we have enough time for questions and things. But yeah, I'm really excited to give the floor to Wang now. If you want to share your screen.
Okay, thank you. Thank you, Dr. Svija. Greetings and salutations to all present. I'm Wang, and I express my gratitude for the kind invitation by Dr. JETZON August. My presentation is to discuss the topic of nitrogen supply in the upwelling of the Midwest region of the South China Sea, the case study of mesopelagic fishes. This research was conducted during my doctoral studies. Our research endeavors in this area started several years ago, and we have already disseminated our findings through some publications. Today, our primary focus will be on introducing our latest work, which has been recently published in the Journal of Ecological Indicators. It is widely acknowledged that the twilight zone and its associated fish stock have received limited research attention, and the exploitation of these resources has been minimal. Consequently, it is imperative to conduct comprehensive investigations on mesopelagic fishes and their ecological significance within the marine ecology. Such studies are crucial for elucidating the characteristics of these species and determining their potential for sustainable ecological and economic exploitation. Previous studies have revealed that the mesopelagic fishes not only are widely distributed in the ocean, but their biomass have reached about 10 billion tons. However, subject to observing and sampling these small fishes, little knowledge has been revealed by previous studies. In the South China Sea, the first investigative cruise was conducted in the last century, and since 2014, we have organized a comprehensive research and emerged some new understandings of mesopelagic fishes. We have organized a special issue in Deep Sea Research Part 2. It includes physics, chemistry, biology, and so on. If you are interested, you can follow it. The Malaspina 2010 expedition cruise has estimated mesopelagic fishes biomass in the global ocean, while it has not studied the complex of migrating behavior. In the South China Sea, we have found two migrating patterns in different water depths. These behaviors have not been well revealed. Thus, more studies will solve the mystery. Most fishes are obtained from deep water. The empty stomachs are often found. Meanwhile, the mesopelagic fishes have a smaller size compared with other fishes. These two reasons lead to the stomach method may not be suitable to study mesopelagic fishes. Thus, we try to use biomarker methods to mirror their trophic interactions. And we also want to reward the nitrogen sources in the upwelling and non-upwelling system. In the northern South China Sea, we get many mesopelagic fishes, and based on their migrating and feeding behavior, they are divided into 5 groups. This work was done by South China Sea Fisheries Research Institute. Traditionally, C13 and N15 are used to study diet sources and trophic position in the stable isotope graph. However, we found the bulk C13 values have not shown their diet sources, and these values just be impacted by the lipid content. We also get 2 special fishes in breeding season. The high its lipid cause the C13 values have more negative values. Thus, removing the lipid effect is vital to applying C13. In the next step, we use the after lipid extraction C13, replacing the bulk C13. In the result, we can see the duplexin, the migrating planktivorous species, and the migrating piscivorous species form the stepwise food chain. Based on the stable-isotop relationship, we can know that these organisms have a predator-prey relationship. So when the sun rises, the migrating piscivorous species and planktivorous species will migrate to the twilight zone to avoid higher trophic species. And when the sun goes down, these species will migrate to the surface water and feed on plankton. Their behaviors are also consistent with pattern 1. In our study, the N15 enrichment is about 1 per ml, less than the nitrogen 15 enrichment than other studies. This is caused by the long temperature, which results in long metabolic and smaller nitrogen 15 enrichment. But other species in pattern 2, the non-migrant and the same-migrant species don't show nitrogen 15 enrichment. Thus, we meet other parameters to show their interaction. The ratio of DHA to and EPA often is used to indicate carnivorous habits. Thus, we use it to replace the nitrogen 15. In the result, we can see the piscivorous species showing difference from planktivorous species. Meanwhile, some non-migrant piscivorous species showing similar to migrant planktivorous species. This also indicates that non-migrant piscivorous species may prey on migrant planktivorous species. However, after removing the lipids in all fishes, the C13 difference are less than 1 per ml. So we can't distinguish whether they have trophic interactions or not. In recent few years, more and more studies have used the stable isotope of fatty acid and amino acid to reverse the interactions in fishes. We also have tried them. In the result, we can find large isotope difference in different species. Thus, we combine C13 of 24 and 6 fatty acid and nitrogen 15 of glutamic acid to show their relationship. The difference can be reached about 4 per ml. Thus, we think the combined method may help reward more details of mesopelagic fishes. This work is done in the early stage. Only 5 fishes have been done in our study. We firmly believe that if we have done more fishes, the trophic interaction will duplicate more delicately. After we knew their behaviors, we transfer our study to the Midwest region of the South China Sea. This area including upwelling system and non-upwelling system, more complex hydrology than the northern South China Sea. Meanwhile, the sampled fish are classified based on area and migrating and feeding behaviors. In the PC result, we can find that PC1 separates them into area 1 and area 2. PC2 separates them into planktivorous and piscivorous species. PC1 and PC2 explain 73% of all data, and some parameters like the fatty acid ratios and the nitrogen 15 are the main loading factors. Ratios of DHA and EP show the carnivorous habits, similar as the mesopelagic fishes in the South China Sea, while the ratio of 18:1:9 and 1:7 show opposite trends. In the migrant plankton fishes, the ratios show similar values. The result reveals that the particular organic matter input from the Mekong River, like the triters, may not impact the fatty acid composition in the planktivorous species, while the same migrant and non-migrant species may be impacted by upwelling system. In the nitrogen-15 results, we found that the mesopelagic fishes have different values between area 1 and area 2. In the same trophic level, we can see the fishes from the upwelling system have 2 per mil higher than the non-upwelling system. This variation also shows in POM and zooplankton. The nitrogen sources may show difference between upwelling and non-upwelling systems. We use a simple tool and isotope maximum model to calculate the relative contribution of nitrite and atmospheric nitrogen. Just to be clear, in the equation, the N15 of particulate nitrogen including phytoplankton and zooplankton. This value is the mean values of plankton and zooplankton. After calculation, we found the atmospheric nitrogen has a larger contribution in the non-upwelling system than the upwelling system. As revealed by other studies, the particular organic nitrogen from the Mekong River Mekong River mainly burned in the estuarine delta area. Thus, the inorganic nitrogen from Mekong River may be the main factor impacting the relative contribution of atmospheric nitrogen and nitrate. In this study, we also found some unknown mesopelagic species. Based on the PD results, we can classify them into different groups. Thus, we think the Biomarker method may be useful to reward the migrating and feeding behavior of unknown mesopelagic species. Based the above results, we know that mesopelagic species have complex trophic interactions and many factors impact the biological composition of fishes. Low temperature may prevent the traditional method to study mesopelagic fishes, and more combined method may be useful to show their interaction. This work was supported by the National Pay Program for Physical Research and the Natural Science Foundation of China. We also appreciate the help of many people from China and Germany. That's all. Thank you.
Great. Thank you so much. That was amazing. So much good work. If people have any questions, just either raise your hand. Oh, Eiley has a question. Nice. Or put it in the chat if you don't want to talk. Eiley, do you want to talk?
Sure. Thank you so much for the presentation. I was just wondering, one thing I've always been curious about, and you may have included this when you're thinking about your project, but how do those del15 values vary with depth as well? And were you able to take that into account? I know with upwelling, that's gonna change the overall kind of nitrogen landscape, but just wondering if you factored that in when you're looking at all your different depths.
Sorry, I can't hear very clearly.
No worries. Can you hear me now?
Okay. But the what is more.
Just wondering if you took into account the change in del15 values with depth, and if they change, would expect them to change.
Sorry.
You know that there are different water depths, and she just wanted to ask or know if the delta 15N will change with the different water depths.
Yeah. You mean the nitrogen 15 charge in different water depths?
Mm-hmm.
I know that. I also have seen one paper in the published in the +1. They have charged that they have studied the mesopelagic fishes from different area. They also showed the nitrogen 15 showed the different values in different area. So I think you are right. The nitrogen 15 will be charged based on the water depth and the area. But we haven't done many fishes, so I can't I don't know the more details.
That's great. Thank you.
You're welcome.
Anybody else got a question? Now is your time. Yeah, just for me, maybe until people are just while people thinking, you found 3 new species of mesopelagic fish. Did you or do you wanna describe them based on molecular analysis or taxon, like just morphology, or will you just look at their function in the ecosystem and not describe them?
Sorry?
So you found you
My
had one
internet is
graph,
not
you found
very good.
3 you found 3
Can you hear me?
different new mesopelagic fish species. I'm just wondering if you will describe them either morphologically or molecularly. Molecularly, is that a word?
Sorry,
That's okay.
王富强，
can
他
you
问的是你最后的那个3的，基本上是最后一张 PPT， 你用那个 Biomarker 的 method 去找到了新的一个 deviation. Yeah, this one.
That one.
Yeah.
You see, you found 3 new species, which is pretty exciting, I think. Will you describe them?
the other people from the yeah. Yeah, this species are got from the South China Sea Fisheries Research Institute.
Mm-hmm.
They can't find they can't find their name from the book and the previous studies. So we can't we give them name. So we just use the unknown species in our study.
Mm-hmm. Yep, awesome. Still pretty exciting, I think, because, you know, mesopelagic is not too far away from surface, but then you find new species. I think it's pretty cool. Awesome. Is there other questions? Let me see if I have anything else. Yeah, definitely really good work.
Thank you.
Super useful for also future changes, you know, if you could detect a change in food, right? You know, because with over time, if you redo the study in a few years, you can see, oh, you know, you have a warmer ocean, maybe they feed on something else or something. So I think it's super useful work.
Yeah.
Let's see if I have anybody else. Oh no, thanks Josh for writing out the questions. I think it's helpful. If there's no other question, we might move on to Eiley. Thank you again. That was well, amazing. Good talk. Well done.
Okay, I stop the share.
Beautiful. Thank you.